So now let's see what happens with my bare hand. Here we go. Ah! Oh, holy cow. Look at that. Ah! Look at the force of that on my hand. Cutting off the circulation in my hand. Whoa. Ah. Oh, holy cow. That is powerful. Ah. 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 Look at that mark it leaves. Look at that bruise. Okay, so the force of this on my hand is definitely not 1,000 pounds. The reason is because it's taking up a small surface area of the magnet, and basically there isn't enough metal in the knife to saturate it to pull it all down towards my hand. So the more metal I have, the more equivalent weight it will put on my hand. But you can see how it's just crushing my hand. That is crazy. Okay, so the first experiment I'm going to be doing is using steel coins. So I have here a bunch of 1943 steel pennies. So these are pennies that were printed during World War II when there was a shortage of copper. So instead of the traditional copper-based pennies, these are steel pennies coated with zinc. So I have my giant magnet up top here, and I have the pennies underneath. So what you can do is you can start to balance the pennies on your hand. Look at that. Oh, if you get them too high, they get sucked to the top. So what these pennies are doing here is lining up with the magnetic field lines. So the magnetic field is penetrating the air, and it's inducing a magnetic field inside of the pennies themselves. So the pennies now become their own mini magnets. Whoa. That is crazy. This might make it get sucked up. 6 pennies. That is so cool. Look at that. It's like they're just floating in air. See if we can get one more. I think this is gonna make them all suck to the top. Let's see. Whoa! So this is a really weird phenomenon because the pennies are attracted to the magnets, but because they're getting their own magnetic field induced inside of them, they want to stick here. If it was just one penny, it would easily fly towards the magnet. But because you have multiple, they become their own magnets attracting each other. And see, it stays even all the way up to here. I can hold on to it. And so what's happening here is the pennies are forming along the magnetic field lines and finding the point of minimum energy. This is the same reason why ferrofluid spikes when you put a magnet under it. But with a magnet this big, not only can you get little coins to stick to it, but you can get big ones to stick to it too. So I have my giant magnet up here on this ladder, stick a 10-pound weight to it. Oh. Another 10-pound weight. Even this far away from it, it's still very magnetic. You can see I can still stick all these coins on it. So look at that. It's crazy that it can support this. Now to get them off. Oh. Okay, and now for my final experiment, my little friends Einstein and Tesla are gonna be helping me. So these are my pet mice, they're called fancy mice. Okay, you can see how it's completely still, not spinning. Okay, so what happens when I bring the magnet near the mouse? Let's see. So notice I'm not touching him at all. See how it's moving away from the magnet? So the mouse was repelled by the magnet. That's called diamagnetism. I can even stop the turning and make it go the other way. See how it's starting to move away? So the mouse is repelling the magnet. So what this is showing here is that animals are diamagnetic. And it's not just this mouse.